I am Dikshit Nayak. I am here to discuss about the concept of reference frames. As all of you know, ADCS is Attitude Determination and Control Subsystem of any satellite system or satellite project. It focuses on determining the attitude and controlling it. Controlling means pointing it in the desired direction. But the question is, before determining the attitude of the satellite, it is important to know with respect to what you are determining the attitude. Okay, if you ask me what with respect to what you are determining, it is the reference something we are using. So what reference is that with respect to what we are using? These references are actually the reference frames or the frame of references. These are the helpful coordinate systems with which we can make our observations. So in this frame of references, there are two types of references. One is the inertial frame of references, one more is it is the non-inertial frame of references. When I say inertial frame of references, the basic difference is it holds the Newton's laws of motions very well. Okay, when I say very well, it holds for the rectilinear motion. What is the Newton's first law of motion says? A body continues to be in a state of uniform motion or its state of rest until it is compelled by an external force. Okay, when I say external force, it is the force that is additional, that is not existed primarily in the reference frame. It is the additional extra force we had applied. So if until that force acts on the body won't changes its state of uniform motion or of uniform the constant velocity, you can say. When that velocity becomes zero, you can say it is the state of rest. Okay, this type of reference frames are called as inertial frames. In the inertial frames, it is not only that the frame is fixed. If already a fixed frame is present and one more frame is moving at a particular constant rate, then that frame is also inertial, because when I say that frame is moving at a constant rate, indirectly I am saying the position of one object is varying constantly with respect to this frame. So the Newton's law holds good for this frame also. So this frame is also inertial frame. When I say non-inertial frame, non-inertial frame is some frame where the frame is accelerating, means the velocity with which it moves is not a constant, it's a varying velocity, so it's an accelerating motion. So okay, let's move into the different types of reference frames. One is the body frame. When I say body frame, we are dealing it entirely with respect to a body. So when I say a frame, the four important parameters we should define for a frame. One is the origin, one more is x-axis, one more is y-axis, one more is z-axis. When I say body frame, the body with which you are considering, if any body, that is the body of analyzation, that should remain static, with respect to that reference frame. If I consider my head as the object of my analyzation, okay, I will consider the origin is here, but in a basic body frame, the body is a center of mass will be considered as the origin. Now for my assumption, I consider the head, and I am considering here the eye as my average of eye. I consider it is the center of mass or the origin. Now from here, from the body there will be three axes, and in general we consider these three axes as the major axis of inertia. Inertial axis we consider the same as the axis of Cartesian systems. In the here this condition also, I consider one axis, another axis, another axis. That is, a body is there, you can consider any of the three perpendicular axes, but in general we are considering the three major inertial axes. With respect to one point of origin, I can measure the position of any point. So this is what a body frame is. Is this inertial or non-inertial? This is an inertial frame because if the frame moves with some constant velocity also, the position of the body changes with respect to the constant velocity of this particular body. But the position of this particular body with which I am considering the inertial frame should remain static. There is no variation in the position of the body of our analyzation. This is the important thing while considering the body frame. Now let's move into the orbital frame. Orbital frame comes into picture when a body moves around another body in a circular orbit, but we know a perfect circular orbit cannot exist, but we are assuming it is circular. That means we consider eccentricity is almost very close to zero, where I can say it is a circular object. Okay, but what is the origin? Origin is the center of mass of the revolving body. It is not the center body, the revolving body. And x-axis defines the direction of the velocity of the moving body, and z-axis is the axis drawn from the center of mass of the rotating body to center of mass of the center body, and y-axis defines the right-handed system. When I say right-handed system, stretch these three fingers of your right hand, and it will define a system where this is first finger, second finger, third finger. It will define it in such a way that the cross product of first and second finger will give the third finger. The direction of the cross product of these two will give this. Now, it's a very important thing to consider in this case is that in the cross product, commutative law won't holds good. It means A cross B is not equal to B cross A. The direction will be opposite. So you can't say this cross in this is this. Only this cross this is this. When I consider some Cartesian system, here the usual thing is x cross y is z, y cross z is x, and z cross x is y. I have z and x in my hand, and I should remember y now. So z cross x is y. So I should point this in z direction, this in x direction, this will give the y direction. This is how the right-handed system is pointed. Now, since it is a rotational motion, and as I told, the spinning body won't have the inertial frame, so it is the non-inertial frame only. The next one we are considering here is the ECI frame, which is called as Earth-centered inertial frame. We are assuming it to be inertial frame, but as all of you know that the moon exerts some gravitational force on the body present around it. So when the satellite present very close to the ECI center, that means the ECI origin, it will experience very little force from the moon, gravitational force. But when it is present far from the origin, that means close to the moon, it will experience a greater force at that particular point of time. So there will be a variation in the force. That means an external force is already present that we should consider the pseudo force. The basic thing is we can apply the Newton's force, Newton's laws even for this particular non-inertial frames also, but we should know what are the pseudo forces already present. Okay, so all that conditions, if you know, then we can apply the Newton's laws for non-inertial frames also. Now, when the ECI frame, is Earth-centered inertial frame. So the x-axis represents the direction from the origin, that is the center of mass of the Earth, to the vernal equinox. So vernal equinox is the condition happens twice in a year. That is when the equatorial plane of the Earth, if this is the Earth, if you say, then this is the equatorial plane that exactly coincide with the center of the sun. At this condition, if I draw a line between the center of mass of the Earth to the center of the sun, then that will be considered as the x-axis throughout the entire rotation of the Earth, and the z-axis completes the rotation of the Earth. When I say rotation of the Earth, if Earth is moving in this direction, this is the axis of rotation. If Earth is moving in this direction, this is the axis of rotation, and y-axis completes the right-handed system. And ECI is an inertial frame, and as I told, it is an assumption, it need not to be inertial, it acts as actually the accelerating frame. Next is ECEF frame, or I can call it as ECR frame, Earth-centered, Earth-fixed, or Earth-centered rotational frame. Here, the origin will remain exactly same at the center of mass, but the x-axis points from the origin to the point of intersection of the prime meridian and the equator. When I say Earth, this is the Earth cross section I'm considering. This is the equator, this is the equator middle line. This is where the latitude will remain 0. and this is the prime meridian where the longitude will remain 0, the vertical line. This is the horizontal line is equator, vertical line is the prime meridian where the longitude will remain 0. So the point of intersection of these two where the both the latitude and the longitude is 0, that point is the x-axis direction now from center of origin, and z-axis gives the rotational axis of the earth, and y-axis completes the right-handed system. ECF not an inertial frame because as the z-axis remains constant only, as the x-axis changes continuously, because as earth rotates the point of intersection also rotates, no. So as the x-axis rotates continuously, it means the y-axis which defines the right-handed system should also rotate, which means that the frame is rotating. So for any spinning body, it is not an inertial frame, it is non-inertial frame. So these are all about the inertial frames we are considering ADCS.